This is Finite State Machines, but like for web applications. A little bit about me. My name is Zachary. Hello. I'm really thankful to be here and be able to present. I love JavaScript in the browser. I am a front-end developer at CrossComm. Okay, so let's say that you are building a shopping site. So let's say this is your site. So you've built it in React. And disclaimer, some of the stuff I'll talk about in this talk mentions React, but the core code we get to later is React agnostic. But there are plugins for React. So anyway, you have this website, shop123. I'll go ahead and log in. And then we have products here. So we have the life-changing pineapple cup, the above average bowl, and the third thing. So let's go ahead and buy one of these things. We'll buy the pineapple cup. And as you can see, it's loading as it's sending a request off to the server. Eventually that comes back, and now we have one item here in our cart. So go ahead and check out here. And we have our checkout page. It's all pretty standard. Insert a few details here and click buy. We wait for that to go through. And then finally, we get this receipt page. And then we're able to then go ahead and buy more things, which takes us back to the shopping page. So a pretty straightforward example. Let's see how we might build this out in React. So on the right here, we have our state, one possible state for this application. So you can see like we have a flag if they're logged in or not, what page we're on. We have what's in the cart, and some flags about kind of our network state. So like, are we currently adding something or buying, or is there a glitch? Is there an error? So as I go through here again, I'll do this again. You'll see the state update. So now we see that is logged in is set to true, and page is set to products, and then this is the rendered result of that. So I'll buy our pineapple cup again. We see something's been added to the cart now, and is adding product as a flag we've set to true to indicate that we're waiting for the server to respond. It finally does. So the change here is adding product as false, but we do have something in the cart, so we see the indicator by the checkout button. So now we're on the cart page. We're going to click buy, and is buying is now set to true. And that goes through, so is buying is set to false. We're on the receipt page, and our cart is now emptied out. If we buy more things, we will go back to the products page. So that works, but there are some issues with that. Do you know where a user is? So for example, when is the user shopping for products? That happens when these properties are set to these values. They're logged in, they're on the products page. They currently aren't adding products and waiting for the result. Similarly, what happens when they're submitting an order? We have these properties here. And this application, this example is pretty small, and so this isn't too hard to wrap your head around. But as you can imagine, as your application grows, and I'm sure some of you worked on complicated web apps before, this can kind of get exponentially harder to wrap your head around. And so not only do we have an issue with looking at the state of the application to determine where the user is, but we also need to parse the source code to examine where the user is as well. And so in a complicated enough application, it could be difficult to be confident what your user is seeing, especially if there's weird edge cases. There are also many unknown and undefined states, and by states here I mean kind of like what the user is currently doing. So for example, what happens if is adding product is set to true, but they're on the receipt page for whatever reason? Or what happens if they're on the product page, but is error is true? I didn't really demo that in the example, but is error was kind of for if there was a error when buying something. And so these are undefined states. They shouldn't happen, but it's possible. And I'd be curious if you've ever heard or said these out loud before. I've never seen that happen. That shouldn't be possible, and nobody's going to run into that. But in my experience developing stuff, it does happen, it is possible, and people will run into it. The other issue is there might be other states you hadn't thought of. So, maybe it's not clear without like some user tests that maybe it makes sense for there to be another page. Maybe it makes sense for there to be other network states that you haven't modeled. And usually what happens is when that happens, you have to kind of shove that into your state, and over time, your really clean and nice state becomes this really disgusting mess. And you don't have time to refactor it. So, is there a better way? Well, you obviously know the title of the talk. So yes, change careers and become avocado farmers. It's like, it actually is finite state machines. Maybe, and I'll get into the maybe a little bit later in the talk. But you might be asking, if you're not familiar with it, what is a finite state machine? So, part 2, what is a finite state machine? Okay, so it sounds complicated. If you haven't been exposed to this in like the computer science field, it sounds scarier than it is. Kind of sounds like it might be a death metal band or an industrial band or something. But it really is kind of a type of flow chart if you really think about it. The machine part might throw you off, but it's not a kind of physical thing, and it's just an abstract kind of diagram. So in a finite state machine, we have some state. Here we have state 1. And then there's one or more transitions, and when we can transition from one state to the other. And in this specific example, all we can do is toggle between state 1 and state 2. So to turn that abstract example into something that might kind of resonate, let's say that you are sleeping, then you might have a wake-up transition, in which case, hopefully all of you are currently in the awake state. Then when you go to bed, hopefully, eventually, you'll become into the sleeping state. So this part of the talk is just kind of a couple examples to reiterate kind of what finite state machines are. So everyone's familiar with the traffic light. You can model that like this. So we just have a 3-light system that changes states. The transitions here are based on time, or potentially if there's a sensor in the asphalt, maybe that's communicating with it. Here we have a soda machine. This is a soda machine simulation. Sodas are $2. So I will insert a dollar, insert another dollar, and then I will have to make a selection. I couldn't resist the tabs versus spaces thing, I'm sorry, but here we go. We have a delicious tab soda and an okay spaces soda. So I will order tabs, but unfortunately, looks like it's sold out. So we'll go with spaces, and ta-da, we have our soda. So what might that look like as a finite state machine? So initially, we're in this take money state, and so we're going to kind of repeat this take money state until a condition is met, and we have our $2. So you can see here, these diagrams can have loop backs, if you will. So I will insert a dollar, we'll loop back, and we're still in the take money state because we haven't reached our total of $2. Insert again, and we reach our $2, and now we're in a choose state, and the LED or LCD is changed into a make selection message. If I try to buy tabs, it's sold out. If I try to buy spaces, it's in stock, and it will dispense my soda again. Get out of here. All right. Forget if this is the last or second to last example, but so we have regex, if you're familiar, or just string parsing, really. We have this contrived sentence that helps my example, Dave's dozy dog. Let's say that we are searching for the string dog in this string. So we could model this with a state diagram. So we start off with state as 0, and that's basically we have nothing. And we have 2 options. We can find a D, which is good, or we can find a not D. And if you have not seen it before, this a weird kind of angular symbol is just another way to say not. And so if we are to get to the D state, we then look for an O. And if we find that, that's great. If we find another D, we can kind of just hang out here and keep waiting for a second D or a third D. If we don't find an O, though, we have to start back to the beginning. Lastly, if we're on the O, all we need is that G, and if we don't get it, we have to start over. So I think you guys know where this is going, but we will go through the simulation anyway. So as it reads these, it's looking for a D. It found it at first, but then it had to give up. Finally, we find a D, and we find an O, but unfortunately, we don't seal the deal. We're back at Z, and then we're back at state S0. But if you can imagine it, we will reach our dog. And I like this effect, so I'll do it one more time. So, and then we have kind of a practical example that might make sense in our world. Here's a network kind of simulation. So we start at this idle state, and we load some sort of request. Excuse me. And so then we reach into this loading state. We have kind of two options. The network could fail or send us some sort of error, and we're in a failure state. Perhaps we've built our application to have a retry functionality, and we can resend our request, in which case we're back in the loading state. And when we get a response, a successful response, we migrate to the success state. Okay, so that covers some examples. Hopefully that sort of makes some sense if you haven't been exposed to these. How do we apply that? So we have our shopping site yet again. This time, let's think about how we can model this in a state machine. So initially, we're in this logged out state. And we only have one option, is we can log in. And when we log in, we move to shopping. While we're shopping, if we add stuff to the cart, we go up to this adding state. Excuse me. And then on the adding state, when that succeeds, we kind of come back to the shopping state. So these don't necessarily represent individual pages of the application, but more of states. So on the shopping state and adding state, we're both looking at the products page, but on the adding state, we have that modal dialog on top that's saying we're working on it, waiting for a response from the server. Then when we're checking out, we can cancel and go back to continue shopping or buy. When we buy, it can either fail or succeed, and then we get to our receipt page, and we can continue shopping. So I think hopefully that's kind of obvious, but I will just go through it real quick. So I will submit, and we're in our shopping state. This time, let's add the bowl. Actually, I didn't make it work with the bowl. We'll keep buying the pineapple cup. And then it's loading. It's finished adding, and now it's successful. We're back at shopping, but this time we have this checkout button. Checking out, we will buy our cup yet again. We really like pineapple cups. It's buying, and then it succeeds. We're back at the receipt. And if we click buy more things, we're back at the shopping state. Okay, so why is this good? There's no mystery states here. They're all enumerated and visible. So you saw in this diagram, the end result was that we saw every possible nook and cranny of this application. So it makes it easy to see what's missing. If once you map out this flow, you might see like, oh, I might need a page between these two nodes. Or in the example, I didn't actually model out what would happen if adding a product to the cart failed. So we might want to add that. And then also great is that the transitions are defined. It's obvious what states a user can and can't go to from any given state. So abstractly, that means, like, for example, on S0, I can only go to S1 and S3. That's defined. I know there's no way for me to jump to S2. And if I'm on S1, there's no way for me to kind of magically teleport to S3. And so what could happen in a traditional application is that these state properties change to things you don't expect because of a bug in the code, and all of a sudden your user's teleported to somewhere you didn't expect, or they're on some sort of page that isn't planned for, and that's when things go wrong and weird. So JavaScript, which is where this gets useful. So we're sort of starting to leave the theoretical world now of finite state machines and entering the practical real world where this kind of can come in handy. So this is a good resource. I have two good resources on building your own finite state machine in an application. If you like tinkering with this stuff, I'd recommend that you read this article and the next one and kind of play around with it. It's surprisingly simple at its core, And you could build one of these in an hour or two or a day or something like that and get it working. So actually, let me stay on that slide in case anyone wants to grab that and hasn't had a chance to, the URL. But these are, if you search Finite State Machines, JavaScript, Google, these are kind of like they come up pretty quickly on the first page, I think. And then this one is from John Bella, which is similar but slightly different on the previous one. And now this is where the code comes in, but I try to keep it pretty light on code. But this is using a library, XState, and I'll talk about Lucy in a little bit later. So XState is a pretty mature library. I had built out a finite state machine using some of those earlier examples I just showed you. And that was working really well, but I started to come across some edge cases that I needed to then build into my finite state machine. It's been a little while, so I forget exactly what those were. But then I had to make a decision. Like, I could keep kind of tinkering with my own little finite state machine, but I knew that this existed. And so I made the decision that I would just try this. It felt like overkill at the time, but they have kind of worked through every little edge case and kind of need that you'll probably run into. And so I was like, okay, I'll use XState. And again, this is agnostic to your framework. So it has bindings for React and Vue, but you don't need any of those to use it, which is great. It's pretty well documented. It also mentions state charts here. If you're familiar with that term, I didn't want to get into it in this talk, but it's similar to the idea of a finite state machine, just more has been added. So if you see that term, it's really interesting to look into, but that's kind of the relation between that and finite state machines. So we're taking a slice of our example from earlier, and we're going to put it into XState code. So we don't have the login state. I'm just sort of looking here at when we're shopping, adding stuff to cart, and then going to the checkout process. So this is what it looks like defining something in XState. We have a machine here. We need to give our machine an ID. And then we can define an initial state. That's where we start. So as you can imagine, we start at this not logged in state. And then we have this object here, which is context. In the real world, when you're using these in your applications, you'll find that you actually, you still need data. So for example, like the shopping cart. And so XState realizes this, and they give you this object called context. You can think about that in React terms as state. It's just confusing to have state in a state machine because you say state too many times. So they call it context, but that is basically a bucket of data which your states can use. Then we go on to defining the states themselves. Here we have the shopping state, and you can see over here that is represented here. And in XState, the transitions are defined through actions, and that's what on is here. So on is where we define our actions. Here I've added an add action, and we tell it to then go to the adding to cart stage, state. And so here's the add action, and then over here is that adding to cart state. If I scroll down, it gets a little more complicated. I have our adding to cart state, again, that's up here. And we have this new property called invoke. Invoke is what XState refers to as sort of an on-enter event. So as soon as we jump to this adding to cart state, we'll run the invoke code. And the reason they went with invoke, I believe, is because this library intends to be backwards compatible with a standard called, I think it's SCXML or state chart XML, and also to be standard with the state chart definitions, which is great, but I think it's a little bit of a learning curve. I find it a little bit weird, but once you start to use it, then it becomes second nature. So anyway, when we invoke, we run the source function. And so this is where we might talk to an API, for example. So here I have some sort of add API, and I'm sending in context.cart, which again is kind of our state machine state or data. And that cart would be the contents of our shopping cart. And then with invoke, you get a couple of things. You get on done and on error. So if our source function returns or is a promise and resolved successfully, then it's going to automatically call on done, and we'll go to wherever we define. So here on done, we'll go to shopping. And on error, so that means I think it's undefined is returned, or if it's a promise, it rejects. We'll go to some other state. Now here I don't have it, I didn't model this, but you can imagine there might be some sort of add to cart, and we might have a fail state here. And then, and I hope you can imagine kind of so forth and so on. The other states would be kind of iterations of the same kind of idea. So I didn't fill them out here. So what's great is I've showed you some visualizations, but Xstate has that built in. It's on the website. So I can define, here's like maybe a fleshed out Xstate code of our machine. So if I run that in update, then we have this visualization. Now it's not quite as pretty because they just algorithmically build it, but we have our not logged in state. If I hit login, so that's a login action, we then transition to shopping state, and we can add to the cart that calls on done when that invoke function completes. And then we're back at shopping, we can check out. Checking out, we can buy our product. When that invoke function completes, we call done, and we are in our receipt state, and we can continue shopping and return back to the shopping state. So what's great about this is as you're playing with it, this is super helpful to visualize if you have any bugs. Obviously, if you have like some source code issues, it's not going to compile. And all that's really helpful as you're building some of this stuff out. So, oops, I didn't mean to click that. 1 second. Control. What is it? Here we go. So I have a real world example. I used to work on an open source project called Obojobo. This was a learning module platform. It's still out there, it's still open source. But this talk isn't really about kind of plugging that. It's more about a real world example of how this helped an application I was working on. So I have this GIF here just to kind of show you what it looks like so you're not curious. But the piece that I'll be talking about is this assessment piece. So students would come to the assessment of these modules, and then they would see a pretest page. Which would give them instructions about what to expect on this assessment test. Then they would take the assessment test, which would be a couple of questions, and then finally they would submit that. That would then process and then show this results screen that you're seeing, that you just saw there for a second. So here are the pages that I talked about. There was a couple of dialogues, so if they lost network connection and came back, we would resume their attempt. If there was an error, obviously we would show them an error. Then we have that results dialog. And then we have a bunch of data to determine what to render. So some of our state values we cared about, and this is not exhaustive, but like how many attempts have they completed? Is there any incomplete attempts? How many attempts do they have remaining? Is there any sort of error? Did we get successful responses? So then as time went on, we added a bunch of features and things exploded. So now we have new dialogues. We need to let them import a previous attempt. We need to, because of changes we made to the application, there were new question types, and it resulted in us needing to kind of save the responses and then send them all at once. So we now needed to let them know if it was taking a while that we are currently sending their responses up. Did that fail or did that succeed? We also wanted them to confirm to submit their attempt in case they accidentally hit the button and they weren't finished, or if they hit the button and they had some answers that they didn't fill out yet. And then the data also increased. So, does this module include importing? What's the responsive when we're sending all the responses? Is this the last attempt? Because now we had that special dialogue. We had a special dialogue that let them know, hey, this is your final attempt. Are you totally sure? It's going to be set in stone at this point. So I spent some time putting XState in the application. Now I didn't refactor the whole thing, although I wanted to after using it. But this was just the assessment, and I came up with these states. It seems like a lot, but going over it several times, it kind of ended up making sense to me that this really was the number of kind of things that a user could do in this assessment. I'm not saying that this is the only way you can do it. What's really cool about XState is you can actually nest state machines. And so it may have made sense to kind of have a nested model too. I think both are valid. But it was simpler for me doing it for the first time to kind of forego that and just stick with one state machine that had everything sort of flat and visible. So a little bit more code. This is kind of a simplified example of what the code was before putting in XState. This is an older application, an older React application. It used a Flux store. So there's things we could do realistically to make this better, is maybe incorporating Redux. Unfortunately, didn't have the time to do that to the project. But regardless, we have things like we end the attempt with this API response, and then imperatively we kind of next show a dialog saying, here's your results. Or we do a check. If this is an incomplete attempt, we need to show them a dialog like, okay, we're resuming your attempt. And then finally, we can do things like, we'll resume the attempt, and then if it doesn't work, we need to show them, oops, something went wrong. And then call on the store to resume the attempt. Once the state machine was in the application, and this, I don't think I mentioned this, but this is specifically looking at the code that just handles mostly dialogues for the application. You saw one of them in the GIF earlier. But regardless, it made this way easier to reason about. So now I just had this big switch statement, and I had all the states that were important to showing a dialogue. So when the end attempt successful state was happening, I could then be like, oh, okay, we'll show them the results of that attempt. Or if we're asking them to resume, we'll show that dialogue. If that didn't work, we'll show them another dialogue. And so once that was in place, it was amazing, because before this was kind of in some pieces, and again, could have been improved with things like Redux, but this really helped out to understand and work on the application going forward. So, preparing for this talk, about a week ago, a friend of mine pointed out this thing which I had not heard of, that he heard on, I think, the Chris Coye podcast, called Lucy. And this is sort of a DSL, its own little language that then transpiles into XState code. So here's what that looks like. Again, this is our fleshed out example of our shop123 site. On the left here, we have our XState code. You've seen this a couple times now. On the right, and forgive the syntax highlighting is a bit weird because there is no Lucy syntax highlighter, but this is what it would look like in Lucy land. So over here, we have a bunch of actions. You can define these inline, but I do kind of like that they have them all put up here at the top. And then we define an initial state. And otherwise, other than this initial word, all these states are kind of in the same definition. We just say state, the state that we want to call it. And then we add our actions over here, and those actions then transition to other states. And we covered the invoke, so that just looks like this. We call invoke in our source function, in this case, our onEnter, so to speak. Is this update cart method. And this update cart method is maybe some API request again. That would come externally and sort of be slotted in here. That's not necessarily defined in Lucy. Lucy is really just more interested in building out your state machine. And I thought this was pretty cool. It has connections with like Snowpack and Rollup. But you could even forego all of that and then just build this on your own in a command line, and then run the command line script to then convert it into XState, copy that, and put it in your project if you didn't want to get it, spend the work to get it integrated. And that works fine. So there are a few things to consider, a couple of cons to go with these pros. XState is a learning curve. I think the terminology is a bit hard. There's a lot of options, and so there's a bit of trying to decide, well, what's the best way to do this? Something I didn't cover is that in XState you can define guards. So what that means is you can say this transition will only happen on this condition. So for example, in our soda example from earlier, we'd have a guard on the transition from taking money to making a selection to make sure that the amount was at least $2. But that's an example of just one feature in XState. I'm sure there's other ways to do the same thing too, and other ways you can model the finite state machine that would also be totally valid. So plan to spend some time pouring over the documentation if you do pick this up. It's not a magic bullet. If you have complicated logic, maybe complicated business logic in your application, doesn't mean that your application is going to, that part's not going to go away. You're just going to maybe move that somewhere else. There's analysis paralysis. Like I said earlier, I made one large state machine. Should I have made nested or parallel state machines? Maybe. Should I have done a whole ground up rewrite? I wanted to, but probably didn't make sense as a business case to spend the time doing that. And of course, as always, this is a tool. It can be used for good or evil, and maybe it doesn't work for you, and that's totally fine. Also, the last half of this talk is really talking up XState, but I'm not necessarily tied to XState. It's just something I used and worked well for me. There are other libraries out there that do similar things, and I encourage you, if you're interested, to go look and research those on your own. But XState ended up being kind of an easy decision for me in the end. Thank you. If you're interested, my site is zachary.com, and that's where I have all my social links and everything. But yeah, that's it. Thank you for coming.